Okay, so now we've got 1/8 times 4 over 8. So multiply straight across. 1 times 4 is 4. 8 times 8 is 64. Okay, so if we divide the top and the bottom by 4 to simplify this fraction, we will get 1 over 16. Okay, so that's as far as it can be simplified. And our last fraction is 4 over 6 times 3 over 5. So 4 times 3 is 12. 6 times 5 is 30. Okay, so let's go ahead and simplify by 2 first. 12 divided by 2 is 6. 30 divided by 2 is 15. Okay, then let's divide by 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. So we get 2 over 5. So that's our simplified fractions. Okay, so when an outcome of an event does not impact the outcome of the second event, the events are called independent events. So that means what they would be talking about is if I were to have a bag of marbles, and I've got 6 green marbles and 6 blue marbles. So if I have a bag of marbles and I were to pick one marble out and I get a green marble, okay, then that green marble that I pick out doesn't impact the probability or the outcome of the pulling another marble out. So for example, most of these examples are going to be like, if I pull out a marble and I put the marble back, that means that the outcome of pulling another marble isn't going to be affected by the one marble I already drew, okay? So where if I were to pull a marble out and not replace it back into the bag, that would affect the other outcomes. But since I'm taking a marble and then I put it back into the bag, then that doesn't affect any of the other outcomes, okay? So to find independent probability, we're going to find the probability of like event A and event B. So the way that we do that is we find the probability of event A separately, and we find the probability of event B. So for example, that would be like in a card game, you have to pick a 4 and a heart, okay? So we could see what is the probability of drawing a 4, what is the probability of drawing a heart, and then multiply them together, and that would be the probability of drawing a 4 and a heart, okay? So let's look at our examples here. In a board game, students draw a card, replace it, okay? That was what we were talking about. Independent event is where we replace it, and then draw a second card. Determine the probability of each event, okay? So here's a couple examples. To earn 50 points, a student must draw a heart-eyed card and then an angel card. So we first want to find the probability of drawing a heart-eyed card, okay? So there's 1, 2 of those. So 2 heart-eyed cards out of 1, 2, 3, 4, 5, 6, 7, 8 total cards. Okay, now let's see how many angel cards we can get. What is the probability of drawing an angel card? Well, I only see one angel card, 1 out of 8. So if we multiply those two fractions together, 2 over 8 times 1 over 8, we get 2 over 64, okay, which would be 1 over 32. So 1 over 32 is actually the probability of those two events put together, okay? So not too hard. You're just finding the probability of one thing, probability of the second event, and then multiplying them together, okay? So let's do the next one. To earn 20 points, a student must draw a sleeping card and then an angry card, okay? So let's see, what is the probability of getting a sleeping card? 1, 2, okay? So there's 2 out of 8 sleeping cards, and then an angry card. 1, 2. 2 out of 8 are angry cards. So if we multiply those two together, 2 over 8 times 2 over 8, we get 4 over 64, which is 1 over 16. Okay? All right, and then the last one. To earn 10 points, a student must draw an angry card or a laughing card and then an angel. Okay, so here's what they've done. They have now combined angry or laughing. So first you have to draw an angry or laughing card and then an angel card. So when it says angry or laughing, you're going to combine those. So angry, 1, laughing, 2, angry, 3. Okay, so I only see 3 angry or laughing cards, 3 over 8. And then times the 1 angel card, 1 over 8 angel. Okay, so 3 over 8 times 1 over 8. That's 3 over 64. Okay, and that cannot be simplified any further. Okay, all right, let's turn the page. And now we're not going to do all these. We're just going to do a couple. Let's see. Okay, let's look at first. Let's do this one. What is the probability of flipping 3 heads in a row? Okay, so 3 heads in a row. Well, that would be the probability of flipping a head times the probability of flipping a head times the probability of flipping another head. So let's start with, if we flip our coin once, how many heads can we get? Well, we can only get heads once out of 2 possibilities. So you can get heads 1/2 of the time, okay? Then we can get 1 head out of 2 possibilities if we flip it again, and then 1 out of 2 possibilities to get a head a 3rd time. Okay, so if we multiply all those together, 1 times 1 times 1 is 1. 2 times 2 is 4. 4 times 2 is 8. So that is the probability of flipping 3 heads in a row. Okay, let's see. Let's do this one. Okay, 2 number cubes or 2 dice are rolled sequentially. Okay, what is the probability that the first number cube shows a 2 or a 3 and the other number cube shows an even number? So we want on our first fraction, our first probability, that the number cube shows a 2 or 3. Okay, so on a dice or a number cube, there's 6 sides. So to get a 2 or a 3, there's 2 chances that you can get a 2 or a 3 out of 6 total chances. Okay, then we're going to multiply that by the probability of the second number cube showing an even number. All right, well, how many even numbers are there on a dice? Well, there's 2, 4, 6. So there's 3 numbers that are even out of 6. Okay, so now we're going to multiply those two together. 2 times 3 is 6. 6 times 6 is 36. Okay, so if we simplify, we get 1 over 6. That is the probability of getting a 2 or a 3 on the first dice and rolling a even number on the second dice. Okay, let's do one more. Okay, let's do this one. There are 6 marbles in a bag. 3 are green and 3 are yellow. If you draw a marble, replace it, and draw another, what is the probability of choosing 2 yellow marbles? Okay, so let's see. Well, if we first pick a marble, what is the probability that we would get a yellow? Okay, well, there's 3 green and 3 yellow. So the probability of getting a yellow first is 3 out of 6. Okay, now we want to get 2 yellow marbles. So if that's the probability of drawing 1 yellow marble, then drawing another yellow marble would also be 3 out of 6. We replaced it, so there's still 3 yellow marbles in the bag. So if we multiply those two together, 3 times 3 is 9, 6 times 6 is 36. So if we divide that by 9, 9 divided by 9 is 1, 36 divided by 9 is 4. Okay, so 1 over 4 is the probability of choosing 2 yellow marbles. Okay, so go ahead and make sure this is in your notes, okay, and then you may go grab the homework.